these centering rings, thrust rings, internal parts for the motor mount are now CNC'd. You can see the thrust plate being CNC'd here for the 98 millimeter center and the 75 millimeter outboards. Those straight lines are all designed to be able to know where the fins are going to go, and also to be able to line up all of these later. Right now you can see the cups to hold in the 75 millimeter tubes. So the stepped ring basically for the thrust ring being CNC'd. And then it'll cut out the entire outer ring with a lip that'll catch on to the outer body tube. So all of the thrust will be translated into the body tube, either from the lip on the thrust ring, or you see all those smaller holes. The larger ones are 3/8 inch holes that will be threaded for a 3/8 inch 16 rod, and those rods will go all the way up through the entire motor mount assembly and carry a lot of the thrust up into other rings. That'll be, all these rings are going to be bolted to the airframe, so there should be no way for the entire motor mount, even for the Q cluster, to rip its way free and break. And then those second smaller holes are for 1/2 inch tubing. That's the way all of the igniter leads will come down for air starts. And then the really small holes near the middle are going to be 1/4 inch threaded. And so here's all the smaller inner centering rings. These center rings aren't structural at all. They're just going to be placed at the edges of where the fins would go, in order to have some structure for the walls, for the epoxy wells that are going to go in place, which will provide an entire kind of an epoxy bath, so to speak, for the fins themselves, so they won't come out. But all these are, relatively thin fiberglass. And then there will also be a anchor point near the top that'll have 2 U-bolts in it, and that'll be a 1-inch thick piece of fiberglass. And that'll handle all of the recovery weight for the entire booster. So it's pretty, that's a pretty heavy piece of the rocket. Probably going to weigh close to 100 pounds alone. So that's why I'm going to be using a 1-inch thick piece of fiberglass there. Anyway, all of this CNCing went pretty well. It took me a long time to get all the parts and pieces CNC'd, but it's done now. And yeah, you can see that centering being cut out, but there were quite a few of these centerings that had to be produced. So over the course of weeks, I finally got everything CNC'd and completed. So there's that 1-inch piece of fiberglass that'll be used for the forward anchor point. Anyway, these are all the parts, well, the interior parts. The aluminum parts are not pictured here, but there's the thrust ring that you saw being CNC'd, and then a forward ring that'll kind of all be bolted into the airframe. There's a lot of holes in that 1-inch piece. I screwed it up a couple times, but I'm just going to epoxy the holes closed that I don't need. But I didn't want to waste the part. That fiberglass is really expensive. So anyway, the next thing was to tap all those holes that need to be tapped. This is the 3/8 inch holes that'll be tapped. Apologies, these are the 1/4 inch holes that'll be tapped. Those inner holes first, and you can see I use this guide that I made out of acrylic. I use these for a lot of things. I have them for like tubes. I have them for flat pieces, and it basically just allows the tap to stay straight the entire time. So use a little tap magic on there, and then the first thing I do is use a tapered. So this is a really thick piece of aluminum. This is a 1-inch thick piece of aluminum. So it's hard for me to get all the way through and keep the tap straight and use the guide. So I'll use the tapered tap first to get about halfway down the hole, and then I'll use the bottom tap to go all the way through. So if you've never tapped aluminum before, just get it started. By the way, that's a Starrett wrench. They're so much better than a lot of these cheap wrenches. But once you get it going, you do about a half turn, then a half turn back. It gets that swarth back out of the hole so that you don't jam it up and then break your tap into the hole. If you snap the tap off into one of these holes, it's pretty much done. It just won't. It's really almost impossible to get it back out. But anyway, once you get, in this case, half the hole tapped out, you just clear out the swarth with some wiping it out and some air. Now use that bottom tap to go pretty much all the way down to the bottom. But as you'll see, like even with that, my guide is a little thick to let me go all the way through. So clear out the holes again, clear out your tap, and then one more time all the way through to the bottom. And then once I've got the hole tapped completely down to the bottom, get your wrench out, and then I just like to put a bolt in just to make sure everything's good. So grab a 1/4-inch bolt, thread it in, and now what will happen? So these 1/4-inch holes that we tapped in, those are going to hold the motor retainer plate. That'll hold all the motors in after burnout and on recovery. So here's a picture of what it looked like with the wood templates that I made beforehand. And basically the next step is going to be assemble the entire motor mount, which I'll do in the next video or post here. But that is kind of what that's just showing a template of what it's going to look like before we put the motor tubes in, and where all those rings are going to go to give you a better idea. So that's it for this video. We'll keep going and make another one soon. Thanks.